For this video, I'm going to graph just a plain old polynomial, very simple. I'm going to do all the stuff I did before, local maxes, mins, all that kind of stuff, domain, range, etc. So this equals x cubed plus 2x squared minus 16x minus 32. Now the first thing I usually do is pick up the domain. With any polynomial, this is easy. It's negative infinity to infinity. The range, I do know what the range is. To be honest with you, I already know some of what this graph is going to look like. This graph is either going to do this, where it has no local max or mins, or it's going to do something like this. I already know it's going to be one of these two, so at least I'll know what it looks like when it's supposed to be done. After the domain, we usually do the intercepts, so let's do that. I usually do the x1s first. So we set the function equal to 0, x cubed plus 2x squared minus 16x minus 32 equals 0. I picked one that is really easy to figure this stuff out. All you have to do is use factoring by grouping. So I can take an x squared from these first two terms. That would leave me with x plus 2. And then I can take negative 16 from the last two terms. And that also leaves me with x plus 2. Of course, this factors more as x squared minus 16 times x plus 2. I told you these were easy, and everybody knows this is a difference of two squares. So I have x minus 4 times x plus 4 times x plus 2 equal to 0. So x equals negative 2 and plus and minus 4. So my x-intercepts, negative 2 comma 0, plus and minus 4 comma 0. For the y-intercept, all you do is set x equal to 0. So that's going to be 0 cubed plus 2 times 0 squared minus 16 times 0 minus 32. So that equals negative 32. So my y-intercept is 0 comma negative 32. Now that we have that, we're looking next for local mins and maxes. I think before I do that, here's what the graph is going to look like a little bit so far is what I have. We have plus and minus 4 are intercepts. So you're going to have a negative 4, you're going to have a negative 2, you're going to have a positive 4. I already told you how it's going to end up going. It's going to go up until it gets there, but then it has to come down and hit this point. But now it must really, really, really dive down far if the y-intercept is all the way down there at negative 32. And then it's got to skyrocket way back up to 4. I'm a little bit off, but that's generally what's going to happen. So I don't know this now where these max and mins occurs. I don't know just yet until I take a derivative and set it equal to 0. The good thing about polynomials is they are differentiable everywhere. So the only place that you're going to get critical numbers are going to be places where the derivative is equal to 0. So let's do that. My critical numbers comes next. And we have f prime of x equals 3x squared minus 4x, plus 4x minus 8. Let me just make sure. That's going off my memory. 3x squared plus 4x minus 16, sorry. And we set that equal to 0. I don't think I'd spend much time trying to factor it, whether it does or not. I have not made an effort to make this thing factorable, so you might as well just go with the quadratic formula. Remember, it's negative b. I'll just sort of verbalize it. Negative b plus and minus b squared minus 4 times a times a c. All of that over 2 times a. So I have negative 4 plus and minus 16. Now what do I have inside of here? I have 12 times 16, which is 192. I'm going to try to do as much of this as I can by hand, but I will allow a calculator to help me a little bit. In fact, many times on an exam, I require my students to do these exactly without decimals of any kinds. So the reason for that is because calculators can do so much for you that if I ask you just to graph it, students will just render a graph that they got off the calculator. So I have to make the students go through this. Plus, it's a good review of your algebra. So let's go on. Let me simplify a little bit more here. I have the square root of 208 all over 6. What goes in 208? Let's see here. That looks like 4 times 52, or 16 times 13. Just real quick, 16 times 13, 8, 1, 3, 4, 6, 1, 208. All right, so this is negative 4 plus and minus 4 radical 13 all over 6. Now remember, when you do cancel here, it's not good enough to just cancel here and here. You need also to cancel into there. So my two solutions then are negative 2 plus and minus 2 radical 13 over 3. So anyways, these are my critical numbers. Remember what we do typically to find where the thing is increasing and decreasing is we'll put these on a number line. So I'll start this one over here, negative 2 minus 2 radical 13 over 3. And then over here, negative 2 plus 2 radical 13 over 3. And I'll pick numbers around inside of this interval, in this interval, and in this interval to test to see if the thing is increasing and decreasing. Now I'll bet, because I already know what the graph looks like, that it's going to be increasing and then decreasing and then increasing. But let's see how it pans out with the numbers. You may not know that because maybe you have a little bit less experience with these than I do. First thing I want to do is get a rough estimate of these numbers so I know about how to pick my numbers. So I'm going to go to my calculator. Let's start with negative 2 minus 2 second square root 13. Hit enter. And then I can divide by 3. So that's roughly, you don't have to be very close, and this is roughly negative 3.1. For the other one, I'll do negative 2 plus 2 second radical 13, enter, divide by 3, and that's about 1.7. So whenever I see this, I see a negative and a positive. The easiest number to try in here for my test is 0. That's what I'm going to try. When x equals 0, what is f prime? Remember, this is the number line for f prime of x. So let me go back to f prime right here. When you plug in 0 for x, f prime is just negative 16. Now then, to the left of here, I guess I'll try negative 4. And see what happens. F prime of negative 4. Not so easy to do this one. That's 3 times 4 squared plus 4 times 4 minus 16. Well, I can already tell this is positive because right here, these two wipe each other out and you're left with just this part. I don't really care what that value is. All I know is it's positive. Then over here, I'll just take 2 as my test. F prime of 2 equals 3 times 2 squared plus 4 times 2 minus 16. That is 12 plus 8 minus 16. I can tell that's going to be positive. So the thing is increasing, then decreasing, and then increasing as I suggested. Now I need to get the y values for each of these critical values. Not the y prime values, the y values. I already know the y prime values are 0. So I need to go back and figure out f of negative 2 minus 2 radical 13 over 3. That equals, if you remember, this thing was negative 2 minus 2 radical 13 over 3 cubed plus, what was the original function? I'm going back to the original. Plus 2x squared minus 16x minus 32. Now, this has come up on various tests of mine, and many students just don't do it. I don't know if they don't believe that the credit is worth the effort to put in, but these are not the worst things in the world to have to multiply out. If you just apply a little bit of thoughtfulness to it. If you'll remember, come back here for a second, we had factored this thing. What did it factor as? There it is. It factored as x squared minus 16 times x plus 2. Let me come back. I'm going to put, now if I plug it in here, I have a lot less work to do than if I try to do all of that. So if I throw in negative 2 minus 2 radical 13 over 3, make that 3 a little better. That equals negative 2 minus 2 radical 3 over 3 squared minus 16 times negative 2 minus 2 radical 3 all over 3 plus 2. Now I'm going to work a couple of things at once here. You may or may not be able to do this in your head, but I'll tell you one thing you can do. Since I'm squaring it, I can wipe away the negative that occurs there. So I'm not exactly blowing through this at blinding speed, but I'm being very careful and deliberate in the things that I'm doing. And over here, I could rewrite this as 6 over 3 so that it has the same denominator as the other part. Okay, now you may or may not be able to FOIL this out, but watch. You do know that you're going to get a 3 and a 3 again because you're going to multiply this to itself. So you'll get a 3 in the denominator twice. So I know that piece will be over 9. Now do your FOIL method. You know that you're going to have 2 times itself will be 4. Then you're going to have 2 times this times this. So you're going to have 2 times 4. 2 times 4 will be 8, radical 13. And then finally, you're going to have this thing times itself. So that'll be 4 times 13. And now that I think about it, negative 16 is 144 over 9. On the other piece, I can now put these together, so I'm going to get 6 will add to the negative 2 to give you 4 minus 2 radical 13 over 3. I realize that I have been making a mistake here. Let me fix my all these 13s. Okay, now what I'm going to do next is I'm going to combine these guys here. If you look, 4 times 13 is 52. 56 minus 144. What is 56 minus 144? I think that's negative 88. Plus 8 radical 13 over 9. I am going to factor an 8 ninths from the first piece. 8 over 9. That will leave me with negative 11 plus radical 13. And from the second piece, I'm going to factor out 2/3. Now it's a simple matter of foiling those out. I'll multiply this fraction times this fraction to get 16 over 27. And then let me go ahead and FOIL this out. Negative 22 plus 11 radical 13 plus 2 radical 13. And then finally minus 13. So I have 16 over 27 times negative 35 plus 13 radical 13. So that's the y value for negative 2 minus 2 radical 13 over 3. So, and that was the one. Let me go back. I am going back again. I wanted to see if it was going up or down. This here, at this x value, we had a local maximum. Now, it may be a global max, but I know right now it's at least a local max because it's going up, it's increasing, and then decreasing. By the way, when you do this kind of stuff here, you look at increasing and then decreasing. They refer to that as the first derivative test to help you in graphing, of course. But let me go ahead and put my point that is a local max so far. Local max. Now, depending on the capability of your calculators, you may actually be able to check this answer. What I can do, the Texas Instruments TI-84 cannot do what I'm about to do, but more powerful Texas Instruments calculators can do it. This is a Hewlett-Packard calculator. I'm going to go to what they call CAS, is what is referred to as computer algebra system. It means it lets me do exact things like this stuff. I'll show you what I mean in a minute. We had the original function, negative 2 minus 2. Now you have to put the only bad thing about it is you have to put multiplication in there, the symbol. But when you enter it, it doesn't automatically make it into a decimal. It keeps it in that format. Now, that was supposed to have been, the x value was supposed to have been divided by 3. So I'll go divided by 3. Enter. Now, what I can do is this. I can store it into a variable. Let me just use the letter T. For some reason, that feels good. Enter. And then, what I'm going to want to do is, because I'm using the letter T, is I'm going to go plug it into the function, the original function. But I'll just use the letter T instead of X. So all I really have to do is bring this calculator a little bit down, and I mimic this. Wherever I see an X, I put a T. So let's go with that. So I got T to the third power plus 2 times T squared minus 16 times T minus 32. When I hit enter, it looks terrible, but then you can hit the simplify, and let's see how that compares with my final answer. There was my final. Let me put it up here so I can compare it to the calculator easier. All right. Well, the over 27 is certainly a nice sign. What is 16 times negative 35? Is it negative 560? It indeed is. And then what is 13 times 16? I think we know it's 208. So my answer is the correct answer. Now, I will let you find the other one, which was a local min. That was at negative 2 plus 2 radical 13 over 3. And I'll just let my calculator do the talking for me here. Now, when I can go, I don't think I can do that, but I can do here. So I can do, enter there. Negative 2 plus 2 times the square root of 13 over 3. And then I can get out of there and immediately store it into the value T, just like I did before. And then I think I can scroll up here. I can take this guy right here and copy it, and then just hit enter and simplify. So, negative 560 minus 208 radical 13. Or maybe I'll make it look just like the other one. Here, you're just simply going to have a negative there too. So I'll have negative 16 over 27 times 35 plus 13 radical 13. And so those are our local max and our local min. So it may look kind of painful at the beginning, but our graph now, if I can remember where our zeros were and everything like that, I had negative 4, positive 4, negative 2, I think. And the graph comes up like this, comes down like this, and I believe it is, I'm going to probably have to do some sort of strange adjustments to get that to come all the way down to negative 32. But then we have, and we know that this spot right here is negative 2 minus 2 radical 13 over 3. That's the x value. The y value there, that was the, see where I can put this, 16 over 27 times negative 35 plus 13 radical 13. And then below, we know that this point down here, the local minimum, occurs at negative 2 plus 2 radical 13 over 3, and the y value was 16 over 27 times, negative 16 over 27 times 35 plus 13 radical 13.